And so I'd like to talk a little bit about how the protocol works and what's happened in the last couple of years since I last spoke here about it. And also I'll do a little demo. Now, normally the way you would use this protocol is you would take, you could write your own from scratch using the Internet Draft as a protocol specification, but of course what I'd prefer that you do is use my SDK and put that in your VoIP client or your VoIP application. It could be a PBX or some other kind of thing. And when you do that, it integrates smoothly into the VoIP application and can do secure calls. It uses SRTP as the media encryption. It negotiates the keys at the beginning of the call and does the key negotiations in the media plane. Now, a couple years ago when I gave a talk on this here, that was kind of a radical approach, but the IETF seems to think that that's a good approach now, and other protocols that they were working on take the same approach. But there's a lot of wailing and gnashing of teeth to get them to think that it was a good approach. But there is an interesting application that we've got here, ZPhone, which sits in the IP protocol stack and acts as an IP filter and lets you run whatever VoIP client you'd like to run. You could run Apple iChat. It runs on Windows. It runs on Linux. It runs on Apple, Mac OS X. It runs on Windows Mobile. It runs on Symbian for mobile phones. I've seen it run on several Nokia mobile phones. But anyway, this thing sits in the IP stack and lets you run whatever VoIP client you'd like to run. We've got Gizmo running here. We've also got Apple iChat. Just to give you an example of it running on two different VoIP clients. Now remember, these VoIP clients don't have this protocol embedded in it. Rather, we're running the protocol as a separate application that has a daemon running in the protocol stack and intercepting all the IP traffic coming in and out of the machine looking for VoIP traffic. So we're going to do a secure call here, just very briefly, with a friend of mine who's running iChat at the other end. And it's going to do the usual thing it does to set up an iChat video connection here. iChat takes a while to start up a video connection. Steve, can you hear me?
I can hear you fine.
Oh, we don't have much volume here. We can't hear anything. Let's see. Do I got to turn up the volume? Now say something.
Now? Testing 1, 2, 3. Can you hear me now?
Yeah, you should get a little closer to your microphone.
Okay.
Okay.
I'll get the microphone.
All right, so what we've got is a secure connection here so that nobody can hear what we're saying. Oops, I forgot about that. All right. So in order to prevent a man-in-the-middle attack, we have to make sure that we're both using the same session key, because in a man-in-the-middle attack, the attacker gets in between the two parties, and you set up a secure connection with the man in the middle, and the man in the middle sets up another different secure connection with the other party. So you've got two secure connections, both of them connected to the man in the middle, but you think you're talking to the other party. And the way you tell if that's happening is if you have the same session key at both ends, then there is no man in the middle. But if the two session keys differ, there must be a man in the middle. And to tell if these keys differ, we compare the short authentication string to see if it matches. And Steve, on my side, it says allow holiness. That's funny. What a serendipitous thing here. We can do a religious conversion here. Does that match what you have on your side?
That does match what I have on my side, yes.
Okay. So I'm going to hang up now, and we're going to do another secure call through Gizmo, a different VoIP client, and we'll see how that works.
Okay.
Okay. Okay, now ZPhone has detected the call is ended, and now I'm going to call Steve back. This one will just be audio. That one was audio and video, and it encrypted both audio and video streams. except I don't know if, okay, yeah, the call started. Okay, Steve, can you hear me?
Go. I can hear you fine.
Okay. And let's see if there's a man in the middle here. The short authentication string is snowslide suspicious. I like that better than allow holiness.
Right. Snowslide suspicious. They don't make these so that it's easy to pronounce, eh?
That's right, yes. We could also display these things in base 32 alphanumeric characters, but I chose to use the same word list that we used to compare PGP fingerprints. All right, well, Steve, that's it. You can.
Okay.
You're free to go.
All right. Take care. Thank you.
So, let's see. I guess I should have made this be the default page for this demo. So this is the website for Zphone. And if you go there, you can download the software that I just demoed. So you can use it on your Mac, your Linux, or your Windows PC to run, to secure any VoIP call from any VoIP client that you already are using now. And it does an ephemeral Diffie-Hellman exchange. There are no persistent keys. It negotiates the keys at the start of the call. It destroys them at the end of the call. What is this? Oh. Yeah. Okay. I'll have to explain that one later. Okay, so anyway, it's ephemeral keys. There's no public key infrastructure. There's no persistent keys of any kind, and it doesn't talk to any servers. In fact, it doesn't use the signaling. It doesn't talk to SIP. In fact, it doesn't even have to look at the SIP packets if you use this application. But of course, if you're integrating it into your VoIP client with the SDK, then you would talk to it through an API, and you would tell it, you know, here's the RTP stream. But all of the protocol is operating through the RTP stream. There's nothing that it needs to do through the signaling. Now, the nice thing about not talking to any servers to negotiate the keys is that the servers are generally owned and operated by the phone companies. Not always. You might have your own server at home. Maybe you've got an asterisk PBX or something. But, you know, for a lot of people, the phone companies operate the SIP servers, and I just don't feel comfortable trusting them with my cryptographic key negotiations. The whole architecture of this thing is designed to get away from trusting the phone companies. CALIA, Communications Assistance for Law Enforcement Act, which requires phone companies to hand over their cryptographic keys for anything that's encrypted, it doesn't apply to the end users. And with Zphone or the ZRTP protocol, the keys are negotiated only by the end users. So CALIA doesn't really have much traction against Zphone. Now, some of you might work for government agencies and might take exception to that. There are reasons why the government has an interest, a legitimate interest in wiretapping. And if they only use that for that and nothing else, it wouldn't be so bad. But we've also been reading in the headlines about massive wiretapping on a grand scale, like at DriftNet phishing. But regardless of the political arguments of whether wiretapping is good or bad, we have to encrypt our phone calls because we're moving away from the public switch telephone network that we've all been using for 100 years, and we're moving it over to VoIP. And while the PSTN was relatively safe from non-government wiretapping, the VoIP environment on the internet is not safe from non-government wiretapping. There's been an asymmetry for a century in the difficulty that the government has in wiretapping versus the difficulty that criminals have in wiretapping. If the criminals want to wiretap the government, it's not so easy. In fact, if the criminals want to wiretap anyone, it's not that easy. They would have to get close to their target. They'd have to get their alligator clips hooked up to the right wires. in some big office building. They got thousands of wires. They have to find the right ones. It's not that easy to do. You certainly can't do it from far away. But the government had a fairly easy time of it. They could go to the phone company and ask for, help, and the phone company would do it at the switch. But that asymmetry and difficulty of wiretapping will vanish as we move from the PSTN to VoIP. It will become possible for organized crime to wiretap and not even have to get close to their targets to do it. One of your PCs in your office network could be infected with specially designed spyware. And I have a link on my website here on the Zphone Project website on the FAQ page. I have a link to a demo of this kind of spyware. And this spyware could intercept the VoIP traffic on your network and record it on disk as WAV files and make it browsable. You can actually follow the link and browse it with your web browser on a network that has this spyware installed and listen to phone calls yourself. And I don't think they're phone calls that you're likely to find very exciting, but they're just phone calls that were put there for your amusement. Anyway, this means that organized crime can wiretap judges and prosecutors and listen to them discussing ongoing criminal investigations, to talking about witnesses and informants, or maybe just calling their wives at home to talk about what time to pick up their kids at school. So think about what it means when that asymmetry of difficulty of wiretapping vanishes as we move from the PSTN to VoIP. At that point, it becomes possible for organized crime to wiretap the cops. And I think that, I expect that there's going to be some debate from law enforcement about the wisdom of having encryption on a large scale as in our infrastructure of everyone's phone calls. And I can understand why they would be concerned about that, but there could be so much more damage to the criminal justice system if organized crime can wiretap judges and prosecutors. So I think that in the long run, law enforcement is going to have to recognize that it's in their interest to have everyone encrypt their phone calls. So if you have a VoIP client, download this SDK and try it out. Just for evaluating, it's free. And it's also, we're doing an open source GPL licensed version if you have an open source VoIP client or an open source PBX. I'd like to open up for questions now, rather than wait to the end because I want to see what you're interested in. Yeah?
Are you doing anything to get this installed in hardware appliances, like maybe the little routers that come with Vonage?
Yeah, that would be a good place to put it. Yeah, there is. I guess the companies that make those things would have to come and talk to me about that. I do have a licensing arrangement with a company that licenses it to companies that build desktop enterprise phones, and in fact, they're also building a box that's a bump in the wire. It's about this big and has two RJ45 Ethernet connectors on it.